Confidence interval for a population mean, example 4. On the basis of the results obtained from a random sample of 100 men from a particular district, the 95% confidence interval for the mean height of men in the district was found to be between 177.22 centimeters and 179.18 centimeters. Find the value of x bar, that's the mean of the sample, and sigma, the standard deviation of the normal population from which the sample is drawn. Well, what do we know? We're given in the question that there's 100 men in the sample, so n is equal to 100. We're also given information about a 95% confidence interval. We see that this confidence interval is between 177.22 centimeters and 179.18 centimeters. So the population mean lies in that interval. We've been asked to find the mean of the sample. Now, if we think about it, how would we have come up with this confidence interval? We would have used the formula for the 95% confidence interval, which says that the population mean, mu, is equal to the sample mean, x bar, plus or minus 1.96 times sigma over the square root of n. We can see from this that x bar, the sample mean, must be at the center of our confidence interval. We used it to get it. So by symmetry, we could see that the average of these two limit values would be our sample mean. So we just get the average of 177.22 and 179.18. So we add them together, divide by 2, and stick it into the calculator. And we see it's 178.5 centimeters. In the second part of the question, we've been asked to find sigma, the standard deviation. To find this, we're interested in maybe firstly how large our interval is. What's the gap between 177.2 and 179.18? So if we subtract one from the other, we see, putting this into the calculator, it's 1.96 centimeters. What we're interested in is actually half of this gap. So if it's 1.96 is the whole interval, we would see what we've plus or minus to get this interval would be half of 1.96. So one side of this interval would be equal to 1.96 divided by 2. We see from the formula that this must be equal to 1.96 sigma over root n. In this question, root n is the square root of 100, which is going to be 10. 10 is the square root of 100, and that must be equal to 1.96 over 2. We could divide both sides by the common term 1.96. So we have sigma over 10 is going to be equal to a half. Therefore, sigma is equal to 10 times a half, multiplying both sides by 10, which is equal to 5. And it's in centimeters. So the standard deviation is 5 centimeters.